Forking paths is the result of several years of research into how ideas from software version control might shape the way musicians perform with digital instruments. It's a modular synthesizer that runs in a web browser with a built-in system for storing and recalling every change in real time. Think of it as getting really creative with the undo button of an editor, but instead of undoing changes, you're revisiting earlier ideas, creating new variations, spinning off new directions, and reworking past versions of your patch as part of the performance, all while maintaining an immutable record of your creative decisions. Forking Paths is made up of 4 browser windows that work together as part of a shared system. The synth view, which is the synthesizer interface for patching. The Patch History window, which is the interface for experimenting with patch change history. The lobby, which is for joining multiplayer sessions. And the Synth Designer, which is for creating custom synth layouts. Each interface includes help overlays. Click on any one to get a quick explanation of what the feature does and how it works. The Synth view shows the synthesizer itself, along with buttons to open other parts of the interface. If you're in a multiplayer session, you'll also see who else is in the room. If it's your first time using Forking Paths, a demo synth will load automatically. It includes an LFO, an oscillator, and an audio destination module, which sends your sounds to the speakers. To start patching, connect the oscillator's output to the audio destination's input. Click and hold a jack, drag the cable to the other jack, and release when the target highlights. You can adjust parameters by clicking or dragging knobs and menus. You can also add patch notes by using the drawing tool. The synth view is accompanied by the Patch History window, which is the primary focus of this project. It is recommended to have both of these windows open when playing. In the Patch History window, you are presented with a dynamic graph of the running history of all patch changes that you've made. You can freely recall any past state, you can recall an earlier idea and make changes without losing all work that initially came afterward. New histories will always branch out from a recalled state. You can create new musical sequences using past states as sequencer steps. Playback and edit previous knob turns. You can save your history and load previous histories. The patch history can be cleared by clicking New Patch History. This also resets the synth state. Changes are represented by nodes in the graph, and their types of change are associated with a color. And more information about a change can be viewed by hovering over a change node. Cable connections are shown as dark blue dots. Cable deletions are red. There are two types of parameter changes, discrete and continuous. A discrete change happens when the player clicks a different position on a knob, causing the value to jump. These appear in the graph as purple change nodes. A continuous change is recorded when the mouse is held down and moved while interacting with a knob. This is logged as a gesture, shown as a light blue dot in the graph. If two patch states contain features that aren't present in the other, a player can choose to merge them into a new patch. This is done by clicking and dragging one node onto the other. The result is a dark yellow merge node. And sequences, which can include versions, gestures, or both, can also be saved to the history. These appear as green nodes in the graph. Patch notes drawn directly into the interface are also stored in the patch history. Each pen stroke is saved as its own change, shown as an orange node in the graph. And the opening state of a patch, whether it's from loading a synth file or starting a new patch history, is always represented as a gray node at the start of the history. You can use the History Query tool to filter the patch history based on change types. The graph can also display just the changes associated with a selected module. The gesture editor allows players to view, playback, and edit recorded knob turns, and also reassign them to other parameters. Each individual value in the knob turn is represented as a point in the gesture editor. The value of each point can be modified by clicking and dragging it vertically. Easing functions can be applied to a gesture to change its shape. For example, allowing players to smooth out abrupt changes or introduce stepped variations. Gestures can be applied to any other parameter in the synth. Using the Assign to Param menu, pick any other parameter, and then click play to observe the difference. Any parameter, whether continuous or discrete, can have a gesture assigned to it. When assigned, the original gesture is linearly scaled to the range of the new parameter. Unlike the synth view, changes made within the gesture editor are not automatically saved in the history graph. Instead, gestures are versioned only when the player chooses to save them. When a gesture is saved, it inherits its parent directly from the source gesture that it was derived from, preserving the visual and structural lineage of transformations within the history graph. The Patch History sequencer allows you to create new musical sequences from any combination of sequencer states. You can assign any change to a step. To do so, first select a change in the graph by clicking it, then, holding either Command or Control, click a lane in the sequencer to assign it. The step's color changes to the color of the change node. Use the right-click button to clear a step. As with the gesture editor, you can save your sequence and it becomes part of the version history. Command or Control click a sequencer change node to load it back into the sequencer. Step lengths can be defined by the user using the drop-down menus, or all set to quarter notes, or determined by their Euclidean distance in the graph. The sequence can be played in forward order or in random order. The empty step mode controls what happens when a sequencer step is empty. There are three options. Pass through, in which the sequencer does nothing for that step, so the previous state continues uninterrupted. blank patch mode, this loads the very first node in the patch history, essentially an empty patch, making the synth silent for the duration of the step. Skip mode. This skips over empty steps entirely. So if only 5 steps have changes, the sequencer behaves like a 5-step sequence while this mode is active. Playback mode switches between monophonic mode, where each step is played as part of the sequence, as has been demonstrated thus far. Polyphonic mode turns each step into its own loop, which results in some really neat glitchy behavior from the synthesizer. Since the system keeps track of the version history of your playing, it means that 2 musicians can play together in the same session. To play with someone, join an active session in the lobby. The patch history will be shared between you, and the current state of the synth will load. This may take up to 30 seconds for synchronization. Both peers can see each other's mouse cursors. Along with actions made in the synth view. The patch history sequencer state is also synchronized across peers, and both peers can start and stop the sequencer independently. The Synth Designer allows you to make new synth layouts. You can select from a palette of several common module types, arrange them however you like, and then save them. They will be saved both to the cloud and your machine. You can then load your synth into forking paths using the synth browser. All synths made by others in the network are available for you to load as well. If you are unable to hear audio, check that the forking path audio DSP is enabled. Go to System and then click Resume Audio. If you still can't hear audio, make sure that a cable is patched from the output of an audio generating module, such as an oscillator, and into the audio destination module. If you encounter any other issues, go to Give Feedback and click Send Bug Report, and then describe the issue.